Here's a video for week 3. Keep in mind there's no quiz on 1014. The unit test is Tuesday 1021. This is the Molar map. This won't be given to you. You will have to know this and either know how to do these calculations or have this memorized. When we go from mass to moles to number, keep in mind that bottom thing can be asked in atoms, molecules, or compounds. In your homework, you're often asked to use 6.022 times 10 to the 23 in 1 mole. You can use that. This would be 4 sig figs, and you can use 6.02 times 10 to the 23 in 1 mole, and this would be 3 sig figs. And really what this means is this many atoms. If you look at the bottom of the periodic table, let's say aluminum is 26.98 grams, and 26.98 grams of aluminum, you have that many atoms, and it's a lot of atoms. It's a huge number, but not just because they're real small. Make sure you know how to do these calculations. I give the answer on the next page. Here it shows how to set it up and solve it. And for this question, you're being asked to go from number to grams. So that's going to be 2 conversions because you have to go from molecules to moles and moles to grams. So here we have given we have that many molecules of bromine. 1 mole is 6.02 times 10 to the 23rd molecules. So make sure that I enter, when I put those in, there's parentheses, and then we convert to moles. Now we have to convert to grams, and since it says bromine, bromine's diatomic. 79.90 is the bottom number times 2, that's 159.80. 159.80 grams per 1 mole. And units cancel out. Make sure you get that number. If you don't get that number, it's probably here we're going from grams to molecules, so we can look at the molar map. We know that one molecule is 4.3 grams. We can start off with given 1 mole is 32.00 grams. Because oxygen's a diatomic, times 6.02 times 10 to the 23rd. 1 mole. Cancel those out. We have 2 sig figs, so the answer is going to have 2 sig figs. So here is molarity. Molarity is big M. Whenever you see that, it's a good idea to just write small m, moles divided by liters. So these words are interchangeable or equations. Molarity means the same thing as big M, like in the last slide. It also means concentration, meaning how concentrated something is. If you put a lot of sugar in Kool-Aid, it's very highly concentrated. If you put just a little bit, then it's less concentrated. Moles divided by liters. Then you will also see brackets. I don't even know if we've seen that yet. But if something has a molarity of 0.8, you can write it like that. So here we have a practice question where we see big M, molarity. Big M is moles divided by liters. Liters we have 200 milliliters, so we need to move the decimal 3 times, 0.200, and big M is 0.21. So to get moles, we're going to isolate the variable 0.21 times 0.2, and the moles is going to be 0.042. To get from moles to grams, you multiply by the molar mass. Molar mass of NaCl is 58.44, and I get 2.45 grams. In question, we have 3 sig figs and we have 2 sig figs. So when you multiply divide, you go with the least amount of sig figs. So the answer for this one at least is 2.5 grams. Then wanted to determine the amount of compounds from that. We'll then have to go from moles to number. And I think we had 0.042 moles of NaCl. To go from moles to total number compounds, we multiply by 6.02 times 10 to the 23rd. And here we have 1.5 times 10 to the 24th compounds. We have 2 sig figs, 2, 3, so the answer is going to have 2. Here's an Alex question. I'll let you work that out on your own, but essentially we have grams and we have milliliters. And we want to find, what is the word that they give? Concentration, moles per liter, so they use 2 things right there. Concentration is big M, moles divided by liters. Since it's in milliliters, we're moving the decimal 3 times. We have to get grams. To go from grams to moles, we divide by molar mass. And that's going to be the molar mass of sodium nitrate. And then we can solve for molarity. The sig figs in this answer is going to be 3 because we have 3 and we have 3. Unless it tells us, yeah, correct sig figs. Now we're going to do mass percent. Now mass percent is not all that difficult. Essentially, you're going to find the mass percent of an element in a compound. And here is the equation for it. Here's some work on how to do that last one. Here is an Alex problem. We have to find, so what is it asking for? Calculate the mass percent of nitrogen. So first we have to find molar mass. Chromium is 52.00. Nitrogen 14.01. Oxygen 16.00. We have 1 chromium, we have 3 nitrogens, and we got 9 oxygens. Because that 3 is going to distribute in, I can rewrite that chromium as CrN309. Then to find molar mass, we're just going to add those numbers up. 9 times 16, 90, 6 times 54, 140. So 9 times 16, 144. You get a total mass of 238.03. And that is the mass, oh, I forgot what this was, 144, I think. So we have to find the mass of nitrogen in the compound. The compound weighs 238, and the nitrogen in the compound weighs 42. It's really not too difficult to just sort of think through it. And we're going to take 42.03 divided by 238.03 and multiply by 100, and we're going to end up with 17.66%. That would be the right amount of sig figs, but here, nearest percentage, So I'll ask it, honestly, I'll just take either one, because if we look at the question, we have 4 sig figs in all of those. Then we go with the least amount after the decimal from adding, and so we should have 4 sig figs in the final question, but maybe that's, so, I'll ask for the nearest percentage, or if you write the right amount of sig figs. So here it's going to be 18%. Either one is fine. Ask it like this, make sure you're able to do one where you can look at a compound. And so make sure you practice this, because I'm thinking I'll ask it like that. Here's a slightly more difficult one. I'm just going to rewrite that compound as N2H8CO3, because that 2 distributes in. We're saying that we have 2 ammoniums, and so that 2 distributes in. So Lewis structures will be covered in week 7, so we don't do anything this week in Lewis structures.